Hey, welcome. Today we're going to talk about equations with fractions. Now, this can be intimidating, and I'm going to show you some of the tricks that have to do with dealing with fractions. But the important thing to remember is that all these problems can be done as long as you break them down into pieces. And here's what you have to remember. We'll go over the fraction parts in just a minute, but remember, there's three things to do when, well, let's say there's four things. So number one, simplify. You're just going to look for an addition or subtraction or multiplication problem that you can do. So if there's two fractions being added together, you can do that. You don't have to, there's nothing special when it's in when it's in an equation. Number two, if there's something being multiplied by x, right? Okay, so let's just say it's 3x equals 5. Then all we have to do is divide both sides by that number, divide by 3. Okay, and that's going to produce fractions, and that's okay. We're okay with fractions. Number three, or if it's been divided and we do the opposite, it's multiplication. Number three, if there's something being added to x, so x plus 3 equals 5, then we do the opposite, minus 3 to both sides. So whatever's being done to x, we do the opposite to both sides. And number four, and this is the big one, we're going to use this one with fractions. If you have a fraction being multiplied by x, then the opposite of a fraction of being multiplied is to multiply by the reciprocal. So we could say divide by 1/3, but instead we're going to say times the reciprocal 3 over 1. Okay, and so if we remember that little fact, that'll help us a lot in solving fraction equations. Okay, now that's all I'm going to say. We're gonna follow those rules of doing the opposite. Whatever's been done to x, we'll do the opposite, simplifying whenever we can, and then we're gonna, once we decide what we're gonna do, then we're gonna turn our minds to how do we do it with fractions. Okay, so here we go. First problem: 1/3 times x. 1/3 x equals 6. Now, what's being done to x? What's being done to x is it's being multiplied by a fraction 1/3. And so we're going to do the opposite of that. What's the opposite of times 1/3? And we may be tempted to say divided by 1/3. And so we'll divide by 1/3 on both sides. But there's a better way to think about this in fraction form. When we're thinking about fractions and division, we divide a fraction, divide by 1/3, by multiplying by the reciprocal. So we're going to say times 3 over 1, times 3 over 1. Okay, that's what we're going to do to both sides of the equation. It means the same as divide by 1/3, but it's just an easier way to think about it. Now, just to get this out of the way, 3 over 1 times 1 over 3 is equal to 3 over 3, which is 1. 1 times x is x. So that's effective. This method is effective for getting rid of the times 1/3. That's what we want. We don't want x times 1/3. We just want x. And that's what we're going to get. Now, what is 6 times 3 over 1? Well, 6 times 3 over 1 is the same as 6 times 3, because 3 over 1 is just 3, and 6 times 3, of course, is 18. So there's our answer. And it turns out this problem, which looks really super intimidating, is actually super easy. And that's the first lesson. These fraction equations are going to be, all of them, so much easier than you think if you just take a little time to think about what would I have done if this was just regular numbers and not fractions. Now let's do that. Okay, let's see if we can do the next one, and I invite you to hit pause and try this one yourself. I think you can do it. Okay, so what's being done to x? X times negative 11/10. What's the opposite of negative 11/10? Well, be careful. the opposite isn't positive 11 tenths. The question is, what's the opposite of times negative 11 tenths? And the opposite of that is times the reciprocal, negative 10 over 11. And we'll do that on both sides. Okay, now that looks really ugly, but let's think about this. Let's think this through on the left side. Negative 10 over 11 times negative 11 over 10. Well, negative times a negative is positive, so the answer is positive. 10 times 11 on top is 110, and 10 times 11, 11 times 10 on the bottom is 110, and 110 divided by 110 is 1, right? So we don't have to write that. We don't write any of that. We could write 1, positive 1 times x, but we don't have to write that. And so now we can see, oh, wait a second, that's the whole point. We multiplied by the reciprocal to get 1, so that would just be 1x, and that's what's left on the left side. That's why we did this. In the future, you're going to be so good at this, you're never going to be thinking about like what's happening there. You're just going to say, oh, we just multiply the reciprocal, it gets rid of the fraction. But for now, it's a good idea to think about like what's really going on there. A negative times a negative is positive. A fraction times its reciprocal is equal to 1. And so we're left with 1x when I multiply negative 11 tenths by negative 10 elevenths. And now we get to go to the other side and say, what's going to be the result? Because it's going to be quite different when I multiply negative 2 sevenths times negative 10 elevenths. Let's slow down. Take our time. First of all, we say, well, what's a negative times a negative? And a negative times a negative is positive. So I'll write that down. Just is positive. Okay. Now, I'm going to think about this. Are there any factors in the numerators and the denominators that are the same? Well, we have 2, and then we have 10, which is 2 times 5, and then we have 7, which is prime, and then we have 11, which is prime. So the answer is, although there's a couple of 2's on top in the numerators, there's not any factors that are the same between the numerators and the denominators. So I don't have to reduce my answer. So I'm just going to do a regular multiplication. I'll multiply the tops together. 2 times 10 is 20. Multiply the bottoms together. 7 times 11 is 77. And so x equals positive 20 over 77. I don't need the plus sign. I could erase that if I want to. That was just to remind myself that the answer was going to be positive. And so x equals 20 77ths. And that's the answer. Well, here's a funny thing. Let's go back to the original problem. It said negative 11 tenths x equals 2 sevenths. Sorry, negative 2 sevenths. Is this true? If we replace x with 20 77ths, what happens? Well, negative 11 tenths times 20 77ths equals negative 2 sevenths. Well, let's do our rules of multiplying fractions. Remember, we take all the numerators and denominators. Instead of multiplying them together, which we could do, we just factor them out and see if there's anything that cancels. So 11, nothing cancels there. 20 is 2 times 10. And there's a 10 here, so that cancels. 77 is 7 times 11, and there's 11 there and 11 there, that cancels. And then negative, oops, I forgot, oh no, it's negative times a positive, so it's going to be negative 2 on top, 7 on the bottom, negative 2 sevenths, that's what we said it's supposed to equal, so this works. This actually does work. So we can plug our answers, even when our answers are ugly fractions, we can plug them in and check to see if they work. So the good news is you'll never, ever have to wonder, did I get this right on the test? You can check it yourself. Okay. Checking fraction answers can be intimidating, so I completely understand if you hesitate to do that. But the good news is that you can do that. Let's do a third problem here. And in this problem, this is a multi-step problem. We have x over 12 plus 1/4 equals 2/3. Now let's think about this. If I had x over 12 plus 1 equals 2, what would I do first? Well, I would subtract the 1 from both sides. And then I would multiply both sides by the 12 to get rid of, and 2 minus 1 is 1, times 12 to get rid of the divide by 12, and then I would have my answer. So I would first subtract 1, and then I would multiply by 12. Well, it's not x plus 1, it's x plus 1/4, so I'm going to subtract 1/4, and then it is divided by 12, so I'm going to multiply both sides by 12. So I'm going to do the same steps, even though some of the math that I'm doing is going to involve fractions. Okay, so see how if I take an equation with fractions and I just say, well, what if it didn't have fractions? What would I do in that case? It helps me to see what I'm going to do. Now I'm going to rewrite the problem with the first step in place. Notice 1/4 plus minus 1/4 is 0, and that was the first step. I subtracted 1/4 from both sides. So that gives me this problem. X over 12 equals 2/3 minus 1/4. Now that's going to take some figuring because I have to figure out what's 2/3 minus 1/4. That's not that difficult. I do know how to do this. Remember, I want to get the denominators the same, so I can multiply the third by a 4th, and I multiply the top by 4. You multiply the 4 by a 3, and multiply the top by 3. So this becomes x over 12 equals 8/12 minus 3/12. Okay, so I just changed my fractions so that the denominators were the same. You may notice that the denominators are all 3 the same now. That's not a requirement. I'm only trying to add the 2/3 or subtract the 2/3 and the minus the 1/4. And so I'm getting those denominators the same, and it's a happy accident that the x over 12 matches up with that. Okay, so now that I have that, I can rewrite this as x over 12 equals, well, 8/12 minus 3/12. So I can subtract the tops, 8. The bottoms are the same, so I can add subtract the tops. 8 minus 3 is 5. Now you probably know what the answer is now. X over 12 equals 5 over 12. Seems obvious what x equals. But let's go through the steps. Remember what's being done to x. We're dividing by 12, so we can multiply by 12, and I can multiply both sides by 12. Multiplying a fraction by its denominator just cancels it out, and we're left with x equals 5. Now, we can go back and we can plug this in. This, again, may not seem like an easy thing to do, but we can say 5 over 12 plus 1 over 4 equals 2 over 3, and let's just check and see. In order to add 5 over 12 plus 1 over 4, I need to get the denominators the same, so I'm going to multiply the 4 by 3 and the 1 by 3. So that gives me 5 over 12 plus 3 over 12. Well, 5 plus 3 is 8. That's 8 over 12. Does that equal 2/3? Well, if I divide 8 by 4 and 12 by 4, I get 2/3. So yes, it does. I could say 8/12 equals 2 times 4 over 3 times 4, and the 4's cancel, I'm left with 2/3. So I can check my answers. I can check to see if it's right. And notice again that these do take time. This is not the kind of problem where you can just do some quick mental calculations and you're done, because there's a lot of complicated stuff going on here. So take your time, write it down. Let's move on to the next problem. I want to show you one that looks, again, these all look initially confusing, but it's not that bad. Remember when we had problems where there was a variable on both sides of the equal sign? So now we have, well, let's just think about this. If it was a equals a plus 5, what would we do? Well, we would get rid of one of the a, like we would, let's make it 2a and 7a, let's say. We would try to get rid of one of the a's. We would subtract 2a from both sides, or we'd subtract 7a from both sides to get all the a's moved over to one side. Well, that's exactly what we're going to do here. We have some quantity of a's. It's a division problem. A divided by 2 equals some other quantity of a divided by 7, plus 5 halves. And so we're going to try to get all those a's over to one side by subtracting a over 7 from both sides. So we have the same expression for a's on one side of the equation. I'm going to move this up a little bit. And let's see, well, what does that look like? If I subtract a over 7 from both sides, that leaves me with a over 2 minus a over 7 equals 5 halves. Right? So all I did is I moved the a over 7 to the other side and subtracted it from both sides. And now I can work on combining those two fractions. I'm not allowed to add them together yet, am I? A over 2 minus a over 7 can't subtract because the denominators aren't the same, but it's easy to get them to be the same. I'll multiply the 2 times 7. I'll multiply the a on top by 7 also. I'll multiply the 7 times 2, and I'll multiply the a on top by 2 as well. And that gives me a new problem, 7a over 14 minus 2a over 14. Now the denominators are the same, and I can do my subtraction. What's 7a minus 2a? Well, that's 5a. So 5a over 14 equals 5 halves. Now let's rewrite this, and I'm going to show you a little trick here. That a, the a is in the numerator of my fraction, but I can also move that and make it into a separate fraction or move it out front. Let me just show you kind of the progression. So 5a over 14 is the same as 5 over 14 times a over 1, which is the same as 5 over 14 times a. Okay, so we can take one factor of the numerator, the a, and we can move it out front. It means the same thing, right? A times 5 over 14 would be 5a over 14. So let's rewrite that. 5 over 14 a equals 5 halves. Okay, so I just rewrote the problem here. And now we ask the question, what's being done to a? What's being multiplied? Multiplied by what? 5/14. So I'm going to multiply by the reciprocal. Multiply by 14/5, and whatever I do to one side, I have to do the other side. Okay, and multiplying a fraction by its reciprocal changes it to just 1, which is 1 times a is a. And 5 over 2 times 14 over 5. Well, we could multiply all this together and then reduce the fraction, but it's easier to think of that 14 as 2 times 7, and then we can cancel the 5s. There's a 5 on top, 5 on the bottom. The 2s, there's a 2 on the top, 2 on the bottom. We canceled everything out on the bottom, so that's going to leave a 1. And we have a 7 on top, 7 over 1, which is just 7. So a equals 7, and that was not expected at all. That a was a really easy answer. Let's check this out here. Let's do a, 7 over 2. I use green so we can see we're checking the answer. 7 over 2 equals 7 over 7 plus 5 over 2. Okay, just checking to make sure my answer right, my question right. Okay, so 7 over 2 equals 7 over 7 plus 5 over 2. Now, I could get all my denominators the same, so I can change them all to 14s. But notice that 7 over 7 is equal to, whoops, just erased it. 7 over 7 is equal to 1, right? So 7 over 2 equals 1 plus 5 over 2. Well, now I get the denominators the same by making that 1 into 2 halves. 2 halves plus 5 halves is 7 halves, and that is absolutely true, so this works. So when a equals 7, this equation is true. Again, checking your answers isn't always any easier than doing the problem, but it gives you some confidence knowing that you did it right. Okay, let's move on to another problem. We only have a couple more left. 1/4 times x plus 1 equals 1/4. Okay, what's being done to x? Well, it's being multiplied by 1/4, and it's being added to by 1. So we're gonna undo the addition part first. So I'm going to subtract 1 from both sides, and then we'll move from there. We'll deal with that 1/4 times x. So when I do that, I get 1/4 x equals 1/4 minus 1. Now I can't do 1/4 minus 1 until I get the denominators the same, so I'm going to change that 1 into a fraction, 1 over 1, and then I'm going to change the denominator of that new fraction into 4s, so multiply by 4 top and bottom. So this becomes 1/4 x equals 1/4 minus 4/4. The denominators are the same, so now I can add or subtract the numerators. 1 minus 4 is negative 3. So 1/4 x equals negative 3/4. Now, we've simplified. That was a lot of work. There's several steps to simplify 1/4 minus 1. Now that I've done it, I can deal with 1/4 times x. X is being multiplied by 1/4. The opposite of times 1/4 is times the reciprocal, 4 over 1. So multiply by 4 over 1. And 1/4 times 4 over 1 is equal to 1x. And negative 3/4 times 4 over 1, well, look at there. We have some common factors in the numerator and denominator. The 4's cancel, and we're left with negative 3 on top and 1 on the bottom, so negative 3 over 1, which is negative 3. Again, surprisingly simple answer for a problem that looked like it was going to be really difficult. We can check our answer. 1/4 times negative 3. I'm going to write that negative 3 as a fraction, putting it over 1, plus 1 equals 1/4. Well, 1/4 times negative 3 is negative 3/4. Plus 1, well, 1 is 4/4. And negative 3/4 plus 4/4 is 1/4. And there it is. So we can check our answer and see that x equals negative 3 is the correct value for x in this equation. Let's do one last problem. And look at this problem and tell me, what would you do first? Again, I'm going to think of this as numbers that are not fractions. So So I'm going to say, well, if those weren't fractions, if they were just regular whole numbers, what would I do? Well, I have an x on the left and the right, so I need to get rid of the x on one side. So maybe I would subtract 2x from both sides. And if I did that, I would go ahead and get rid of this plus 2 by subtracting 2 from both sides. And then I would have some number of x's, right? It's only one x in this case, but this made up problem. But whatever number of x's I had here, I don't know what it is, but if there was some number of x's there, I would divide by that same number on both sides. Okay, so that's what I'm going to do. I'm going to get rid of the plus 2 by subtracting 2 from both sides. I'm going to get rid of the 1/2 x by subtracting 1/2 x from both sides. And then I'm going to deal with whatever number ends up in front of the x on the left there by dividing by that number on both sides. Let's rewrite the problem. Let's get rid of all my practice work, my thinking about how I would deal with this algebraically. So we're going to have 1/3 x minus 1/2 x equals 8 minus 2. Notice that I canceled out the 2 minus 2 and the 1/2 x minus 1/2 x, and I'm just left with 1/3 x minus 1/2 x equals 8 minus 2. So I wrote that down because, of course, 8 minus 2 is easy, but what's 1/3 x minus 1/2 x? Well, I just need to get the fractions to be the same, and I can then combine like terms. So if I get the same denominators, 3 times 2, and then the 1 times 2, 2 times 3, and the 1 times 3. So I'm going to end up with 2 over 6x, 26x minus 36x equals 8 minus 2, of course, is 6. Well, what's 2/6 minus 3/6? That's negative 1. The denominators are the same, so I can add the numerators, 2 minus 3. And that's exactly what we predicted. Some number of x's equals some other number, equals 6 actually. So what's being done to x? It's being multiplied by negative 1/6. So we're going to divide by negative 1/6, or we're going to remember that division of a fraction is the same as multiplication of its reciprocal. So we're going to multiply by negative 6 over 1. I'll put a parenthesis around the negative 6 over 1 so that I don't get that negative sign mixed up with a minus sign. Multiplying a number by its reciprocal, fraction by its reciprocal, gives me 1. 1x equals, now 6 times negative 6 over 1, we can think of it as negative 6 over 1 is just negative 6, or we can think of 6 as being 6 over 1. Either way, 6 times negative 6 is negative 36. And the denominator is still going to be 1. 1 times 1 is 1. So x equals negative 36. Now this is a funny one to try to check our answers on. Let's go back to the original problem. 1/3 times negative 36 plus 2 equals 1/2 times negative 36 plus 8. Now 1/3 of negative 36, 1/3 of means divided by 3, so 1/3 or negative 36 divided by 3 is negative 12. 1/2 just means divided by 2, cut in half. 1/2 of negative 36 is negative, let's see, 18. Now negative 12 plus 2 is negative 10. Negative 18 plus 8 is negative 10. Hey, look, negative 10 equals negative 10, which is true, so therefore my answer, x equals negative 36, must be true also. All right, well, that was a lot of work. It is a lot of work. Be ready. Get a snack. This is not easy stuff, but it's all stuff you can do as long as you're willing to break it down into little steps and just do each little step at a time. Sometimes you can simplify a problem by thinking about what you would do if there weren't fractions. But then you just do what you would do with the fractions, and you add, subtract, multiply, divide fractions in the normal way. You can do this. You got this. Thank you very much for watching.